right, folks, we are in section 7.4. So we are we are going to solve rational equations. We've been doing a lot of stuff with rational expressions. And so we're going to solve rational equations. All right, abbreviate that. All right, this is topic number 14, by the way. And so now, basic idea is that, okay, rational expressions, remember, those are fractions, and we're going to have algebraic expressions in rational expressions, but then we're going to go beyond expressions and start putting equations in there and solve for a variable. Okay, so now, basic idea, what is a rational equation? Let's actually get that into our notes. Okay. All right, so it is an equation. So one with at least one rational expression. So that's our threshold. We have an equation, and there's at least one rational expression in there. Right? Then, oops, I don't know why I capitalized that. Then we are dealing with a rational equation, right? And so, if you go back and you take a look at some sort of examples like this. So if you say, okay, one of the things that we took a look at was something like this. So if you had something like this, 5a over 12 minus 7a or 18, and this were equal to 1/4, okay? So there's actually an expression we've taken a look at in the past, but now what I'm doing is I'm actually, before we were doing things like adding, subtracting, etc. And so when we take a look at this and we say, okay, well, wait a second, now I'm setting it equal to something and I want to solve for A in there, I need a strategy in there. Okay, so I'm going to solve for A. Now I'm going to point you to part of your textbook. So this is from my own lecture notes here. But if you go to page 662 of your textbook, if you've got it handy, then that can be helpful. And there are basically a bunch of steps that your authors lay out over here. I've got a photocopy of it. And so you're going to first of all look and see, is there any restrictions that you have on the denominator? You're going to then find the least common denominator, so the LCD. Now here's the new thing. So this stuff we've done before, steps 1 and 2. Step 3, what we're going to do is we're going to clear the fractions by multiplying both sides of the equation by the least common denominator. All right. Then we solve the equation. And then the last thing we do is just check and see, do we have any extraneous solutions? Are there things that, do they actually work in the original equation in there? All right. So steps 1 and 2 are not new. Steps 3, 4, and 5, well, 5 checking is not a new thing, but 3 and 4 is what the new part is, and particularly step number 3, where we clear the fractions. And we'll make a note of that as we go. So we're going to apply this strategy to this. All right. So step number 1 that was in there, okay, that is looking for, are there any restrictions that we have in here? And so if you look in here, we've got no restrictions. Right. If you look at that, okay, there's no way to make these denominators zeros. If you think back to when we were thinking about what those restrictions are, there's nothing to worry about in terms of that, right? And so, okay, so step number 1, good. We're ready to go. All right, step number 2. Okay, so now if we look at this, we need to get, okay, so here what we're going to do is we're going to find the LCD. All right, now if we go back, we've actually done one like this already. All right, so 12 as a denominator, that is the same thing as 2 times 2 times 3. 18 as a denominator. I'm going a little quicker because we've done this before. 18 is, okay, so that is 2 times 9. So in other words, that is 2 times 3 times 3. All right, so if you take a look in here and you say, okay, what's the most either of these occur? I've got 2 factors of 2 here. I've got 2 factors of 3 here. And that is going to make it so that my least common denominator is going to be 2 factors of 2, 2 factors of 3. All right, so 2 times 2 times 3 times 3, 4 times 9. And so I'll keep it green, why not? Right. So is equal to 36, like so. All right. So there we have got step number two. And step number two is find the least common denominator of all denominators that are in the equation. We had two different denominators. So there's our LCD. Okay, now we got to go to step three. All right, step three. This is the new one. Clear all denominators by multiplying both sides of the equation by the LCD. All right, so let me go up here. Oops, some blue. And let me write out my equation again. So I'm going to say, okay, I've got 5a over 12 minus 7a over 18, and that's equal to 1/4. All right, now I'm going to multiply both sides by my LCD, 36, like that. Okay, so now this, as the author claims, and it does work, this is going to clear our fractions. It's going to clear the denominators, right? Because the denominators are what's making this difficult as an algebra problem, right? So when I multiply 36 through here, all right, okay, what have I got? I have got 36 over 12. All right, these are going to cancel so that I have basically 3 times 5a. All right, so now where that 3 came from, that's the 36 over 12. Over here, I'm going to have 36 over 18, right? So that is going to be minus 2 times 7a. And that is going to be equal to, all right, 1/4 times 36. All right, that's going to be 9. So notice that these are products. 36 over 12, 3. 36 over 18, 2. 36 over 4, 9. All right, so let's clean that up a little bit and say, okay, that means we've got 15a minus 14a is equal to 9. Oh, this is going to work out pretty nice because I go 15 minus 14. Oh, okay, so a is equal to 9. All right, so right now we have a solution. A is equal to 9. All right, so we have done, I should have written this in here. So we did step number 3, and then I jumped right into step number 4. I suppose I should call this right here step number 3. Oops. And I should call this right here step number 4. All right, again, page 662 of your text. All right, so now we got to, I solved the resultant equation. I did step 4. I got to do step 5. I got to look and see, okay, first of all, does it conflict with any of my restrictions? It doesn't, because I didn't have any restrictions on this one, but I do got to go back and check and see if it worked. So I got to go back into the here and say, all right, so if I'm going to do step number 5 in all of this, then I'm going to have to go back and say, all right, step number 5 is going to be, all right, go back to my original equation. 5 times 9 over 12, right? Minus 7 times 9 over 18, like that. All right, and then is that going to equal 1/4, like I'm hoping it does? All right, so let's do a little, what I'm going to do is I'm going to do a little cancellation in these, right? So I've got 9 over 12. Well, that's the same as 5 times 3, 5 times 9 over 12, 5 times 3 over 12. This is going to be the 9 and the 18 are actually going to cancel. So this one I'm not going to do anything with yet. I've got 7 times 9 over 18. Is that indeed equal to 1/4? All right, so now let's do some cancellation. All right, so 3 and 12 will have a cancellation. All right, so now convince yourself that if 3 cancels with one of the 3's in here, I am going to have 15 over 4 for this term. Take a look at that. Convince yourself that you can make that 15 over 4. Pause if that does not make sense and to do a little cancellation. Over here, this one's a little easier. 9 and 18 going to leave me with a 2. And I'm going to have 7/2 here. And now I'm just going to see what does this equal to. Oh, got to get a common denominator again. So what am I going to have? I'm going to have 15 over 4 minus 14 over 4. And 7 over 2. Oh, 15 over 4 minus 14 over 4. That is 1/4. I am going to go check. We got it. All right. So that is how we solve rational equations. So let's do some more of that. Here, actually, keep that one handy. All right. Let's do another one that's not too terrible, and then we'll try one that's even a little bit more tricky. Okay. So what if we want to solve for h? Now, what I'm going to make this a little trickier is I'm going to put something in the denominator. So if I had 3 over 4h plus 2 over h is equal to 1, and I wanted to solve for h, right? Okay, so number one, my restrictions. H can't be equal to 0, right? So that is a restriction. If h is equal to 0, I've got zeros in my denominators. All right, so h can't be equal to 0. If that's a solution that I get, I have to throw it away. It's not valid. Okay, so that's the first step. All right, now we got to find our LCD. Step number 2. All right, LCD here. Okay, now, so I've got 4h and I've got h. Okay, so 4h. And I mean, who doesn't like 4h? My mom was in 4h. All right, 4 times h, that is 2 times 2 times h. I'm belaboring this a little bit. And h, well, h is just h. Okay. All right, so I've got h occurs once, 2 occurs twice. Wait a second. Okay, so my LCD, you probably saw this just by glancing at it. My LCD is actually 4h in this. All right, so 4h. All right. My mom would be proud. Okay, so now what I'm going to do, I'm going to clear the denominators, and the way I'm going to do it is I'm going to multiply both sides of my equation by my LCD. Right, and so let's go ahead and do that. I'll do that instead. I got 4h times 4h. All right, so whatever I do to one side of the equation, better do the same thing to the other side of the equation. And all right, so this is going to clear out my denominators, because when I multiply this through, okay, I'm going to have basically 3 times 4h for that one over 4h, and you can see there's going to be a nice cancellation there, and this is going to be 2 times h all over h, and this side 4h. All right. And so, all right, then H's are all going to cancel. So these two H's, these two H's, they're going to cancel. This 4 and this 4 are canceled. The first one is actually pretty simple. We've got 3, and then this one, okay, just the H's are going to cancel. So I'm just going to be left with an 8 for this one. And so it's saying that 3 plus 8 is equal to 4H. And so that is saying that 4H is equal to 11, and go there. That means that h is equal to 11/4. All right, so that is, and I should say that I have done step 4 right there, solving the equations. So I got only one more step. Got to check and see, because first of all right, no problem there. 11/4 is not 0, so that doesn't cause us any problems with our original denominators. All right, but then let's do our check. Let's go back to our original equation. And all right, so let's see, we'll do this in green. So we're going to have 3 over 4 times 11/4 plus 2 over 11/4. All right, that is going to equal, all right, so here the 11, the 4's cancel, is going to be 3 over 11. That's this term right here. That 4 and that 4 cancel, leaving me with 3 over 11. This one, I've got in my reciprocal, or in my denominator, I've got a fraction, which means that I can actually flip that over and make it multiplied by the reciprocal, because if we're dividing by a fraction, that's the same thing as multiplying by a fraction, by the reciprocal of the fraction. And so that's going to come up, and I am going to have the 4 coming up to the numerator is 8. And I'm going to be left with the 11 down in the denominator. So, okay, 3/11 plus 8/11. All right, that works out. I'm going to have 11 over 11, and that is indeed equal to 1, like we wanted it to. So I'm going to check on that one as well. All right, let's step up the complexity a little bit more. And so let's get into some of those more complicated rational expressions, put those into our equations now. All right, so I've got x plus 2, x plus 5 over x plus 2. That's going to be one term. And I'm going to add to that 3 over x squared minus 3x minus 10. And I'm going to say that is equal to 1. All right, so kind of like this one, except a little more complicated. Oh, yikes. Trinomial here, binomial there, binomial up in the numerator. Oof. Okay. All right. So first thing, we got to check this out. All right, is what do I have restrictions? Now, first of all, I can already tell I can't have x equaling -2, right? Because this denominator is going to be 0. So I've got a restriction there. All right. And so, but one thing to notice is if I look at this particular denominator, that's going to factor, and I'll be able to take advantage of this when we do the LCD. But if I were to factor this one, I'd say, okay, x minus 3, x minus 10, or x, minus 3x minus 10. Okay, so that is going to be a plus 2 and a minus 5. Right? So we've been doing this quite a bit, so I made that kind of fast in there. But notice, so this denominator right here has x plus 2 and it has x minus 5. This one has x plus 2. So in terms of the restrictions, what we can't have as an answer is x equals -2, or we can't have x equaling +5. So I'm going to put it can't be equal to that in there. A little bit of smudge on my ink there. Okay, so all right, so we got this as restrictions. Step number 1. All right, now step number 2, we're going to have to find the LCD. Now, if I take a look at this, my LCD, all right, so, okay, this one just is x plus 2, and we've done this before. Actually, with these particular ones we've done in class. Okay, so this has x plus 2 occurring once, this has x plus 2 occurring once, this has x minus 5 occurring once. And so if you go back and you look at when we did this before, we are going to get the same thing, and that is that x plus 2 and x minus 5, or times x minus 5, that is my least common denominator for these two. Again, you're looking for all the denominators that you have, and in here we've got these two. Okay. All right, so there's my least common denominator. All right, now step number 3. I am going to multiply both sides of the equation by my least common denominator. So I'm going to have to be a little careful with my space here. Okay, so here's my equation. And notice that I am writing this particular denominator as the x plus 2x minus 5. It'll make it a little easier to see how things cancel in there. Okay, so there's my original equation. I'm going to take that original equation and I'm going to multiply by my x plus 2x minus 5 by my LCD. Oop. All right. Myself still left myself a little more space, and then we'll do the same thing here. Whatever I do to one side, got to do the same to the other, like that. All right, now this is going to clear out my two denominators. So for the first one, when I multiply this term by this term, the x plus 2's are actually going to cancel, and I am going to be left with this one, x minus 5 times x plus 5. Right, so because I've got all of this times this fraction, the x plus 2's are going to cancel. So then I'll have my x minus 5 factor, my x plus 5 factor. All right, so did indeed clear out the denominator. All right, now this, I put the parentheses here. This distributes over to this, but then both the x plus 2 and the x minus 5 are going to cancel with this one. And this one, I'm just going to be left with 3. 3 over 1, effectively. Right? And that is going to be equal to x plus 2 times x minus 5, like that. All right, so now we have got to solve this. All right, now I am going to actually have to multiply this stuff out because I'm going to set this up as a trinomial and I'm going to see if what I need to do in order to solve for it. And so let's take a look here. All right, okay, so I'm going to use FOIL. This is going to be x squared. All right, minus 25. Right, and then plus 3. All right, so now take a look at this. The middle term is going to cancel, so I'm going to have x squared minus 25. Now, this is the difference of two perfect squares idea right here. Trifoil on it, and make sure you get to x squared minus 25. And I've got that extra term of 3 in here. And then on this side, I'll do FOIL. I will not, this one I don't really have to do FOIL. This one started as already know what that's going to be, although you could just apply FOIL there and you'll get x squared minus 3x minus 10. All right, something nice will happen here. I'm going to try to get all the x terms to one side. I'm going to try to get things that don't have x to the other side. All right, so I'm going to get rid of this x squared and move it over here, although you might be noticing those are going to cancel. I'm going to take the 3x and move it over to the left-hand side by adding 3x. All right. And now these two right here combined are a negative 22. I am going to pay attention to this. I am going to add 22 to this side because I've got negative 25. I've got positive 3. That is a positive 22. That will get all my non-x terms over onto the right-hand side. So again, what I'm trying to do is get all my x's to one side, get all my non-x's over to the right-hand side. Now, if I didn't notice that the x squared was going to cancel, I might have just put everything onto the left-hand side and turned it into a quadratic equation, but I do not have to do that because x squared minus x squared is 0. All right, so this side, all I'm left with on this side is 3x. X squared cancels, 22 and the 25 and negative 25 and 3 cancel. All right, on this side, what do we got? Gone. Gone and 12. All right. So with this, if I divide by 3, I am going to end up with x is equaling 4, like that. So let's do a check on this. Again, that is step number 5. So we have now solved, got a solution. Oh, and I probably should, if I'm going to do my due diligence on this, I go back and double check and say, all right, is it one of the restricted ones? Nope, it's not. It's not -2. It's not 5. We're good there. So let's take it and let's plug it back into the original equation. So if I plug in a 4 up here, I'm going to have 9. If I plug in a 4 down here, I'm going to have 6. Right, so x plus 4 divided by x plus 2 plus 3 over, all right, so x squared will be 16 minus 3x will be minus 12 and minus 10. And the question is, does that equal 1? So let's see what we end up with. All right, so 9, 6, I'm going to keep as it is. But this I'm going to add up what I've got in the denominator. I've got 16 minus 12. All right, that's 4 minus 10. Oh, okay, so I've got 3 divided by -6. Okay, so now 3 divided by -6 is the same as -3/6. So I can actually bring that. It's going to be handy for me. And that is, so I've got my 9/6. And then this 3 over -6 would be the same thing as -3/6, like that. Right, the universe is being nice to us. I've got a common denominator here already. And what am I going to end up with? 6 over 6. And that indeed is 1, like so. All right. So we are in good shape, and I'm going to call that check. We got it. All right. Let us do another one. Let's get this out of here. Okay, let's put three denominators in there. Let's be brave. Let's be brash. And okay, and all three denominators are going to have variables in. Variable will be y, and why not? Okay, so I've got 4 over y squared minus 4 equals y minus 2, 1 over y minus 2, and 1 over y plus 2, like that. Okay, so now checking this, I need to look for what's restricted in this. Okay, so restricted in this, do notice that if I look for the LCD in all of this, one thing I'm going to need to use is the fact that this y squared minus 4, oh, that's the difference of two perfect squares. That's going to be product of those two conjugates. So we've seen that one over and over again. And so notice, oh, wait a second. If I look at this denominator and that, basically I've got y minus 2 and y plus 2. All right. So our restrictions, y cannot be equal to -2, cannot be equal to +2. Right? We have that. The denominators will be 0. In fact, we'll have at least two of the denominators being 0 if we have that as one of our solutions. Okay, so take a look here. Okay, so now we got to get our LCD, right? Well, by factoring this, I actually got a really good jump on what our LCD is going to be, because this denominator is these two factors, y plus 2, y minus 2. And each of them is just also one of those factors. So y minus 2 and y plus 2 both occur one time in there. So my LCD just so happens to be that same y plus 2, y minus 2. Okay. All right, so we got the LCD. Now we're going to multiply both sides of the equation by that, clear the denominators out of the fractions that we have. And so, all right, so let's see, what do we got here? We have got, 4 over y squared minus 4. That is going to be equal to 1 over y minus 2 plus 1 over y plus 2. Right? And we're going to multiply both of those by this LCD right here. All right, so this one right here, okay, that is the same thing as me multiplying by y squared minus 4. And over here, I am going to actually keep it in its factored form like this. These two are equivalent. So convince yourself I have multiplied both sides of the equation by the same thing. All right, so this y squared minus 4, this y squared minus 4, those are going to cancel. I'm going to be left with 4 on the left-hand side. Now, when I take this and I multiply it by the first fraction, this first one here, the y minus 2 and the y minus 2 are going to cancel. That is going to leave me with that y plus 2. So like y plus 2 survives when multiplying here. It's going to be basically the reverse for this one. It's going to be y minus 2. Right, so end up with that. Okay, all right. And so what have I got here? This 2 and that -2 are going to cancel. I'm going to end up with 2y equaling 4. All right, so that should not be a big stretch for you to take a look at that and say, okay, that is saying that my answer is y equaling 2. And all right, okay, what? I actually did my step 4 in there. I keep forgetting to write in. I'm doing step 4 when I'm solving. All right, step 5, my check. Well, right off the bat, I can tell I'm in trouble here too, and say, okay, wait a second, that's not going to work. There is no solution. Right? That's not one of my allowed values in there. And what you can see is that if I go up to the top, if I were to just try to plug that back into my original equation, I'm going to catch that because I would go, okay, what have I got here? So I've got 2 squared minus 4. Oh, 0. Yikes. No dice. But it's also going to be the case over here. 1 over 0 and then 1 over 4. And they're going to say, okay, no, undefined. That doesn't work. All right. The only solution to this, positive 2, doesn't actually work. The only thing that came out of the solution process, but we see that it's extraneous. This is, there's no solution to this. And so, all right, no solution, extraneous. And there is actually, if we allowed ourselves to have imaginary numbers with the square root of -1, there would be a solution to it. But in the real number system that we are using for our class, no solution. Okay. All right, so let's take a look. Now, sometimes, so this one we had numbers, all right, and now I'm going to claim that sometimes we have the following conditions, all right, and that is sometimes there are multiple variables, and what we want to do is we want to solve for the variable, one variable in terms of the others, right? Okay, so I would say, and we want to solve for one of the variables. And I'll put a little extra on here, and I'll say that in terms of the others. In physics, we do this all the time. You're trying to get a solve for a particular variable. You don't necessarily want to plug numbers in right away. You want actually a general formula that you could plug lots of different numbers into, a lot of different variations. So what you do is you leave all the variables as variables, and you just say, okay, which one am I wanting to solve for? Well, let me solve for it in terms of the other variables, and that's what we're going to do right now. Right. So this is what's going to be a little different about this one is that there are going to be multiple variables. So let's suppose we had a variable s over a variable k plus h, and that were equal some other variable e. And let's suppose that we are asked, let's solve for k. Okay, so let's rewrite this in terms of k. All right. Now, so what we're going to do here is we are basically going to again, just like before, we are going to figure out what our LCD is, and we are going to use that to get rid of the denominators that are in here. Now, the one thing is that there are going to be restrictions on what K and H could be in here, what combos. We don't actually have to worry about what the restrictions are when we're leaving it in variable form. We definitely couldn't have a situation where K and H added up to 0 with any numbers, but we're not actually going to plug numbers into this, so it's not something we're going to worry about in solving. So we're actually going to kind of jump to part 2 of this, and we're going to say, all right, well, what is the LCD? Well, this one's actually pretty easy. There's only one. I mean, this has an implied over 1 on it, but my LCD is basically just going to be K plus H. So what I would do with my equation is I would say, all right, I've got S over K plus H. I've got that equaling E. And so what I'm going to do, I'm going to multiply both sides of my equation by K plus H, all right? And I'm going to do that for this one as well, like that. All right. And so this K plus H, this K plus H are going to cancel each other out. This is going to leave me just with S on this side of the equation. On this side, what I'm going to do is I'm going to distribute the E through here because I'm ultimately wanting to solve for K. So I got to kind of get these separated in here. And so I'm going to end up with E times K plus E times H. All right. Now, if I'm wanting to solve for K, I want to get K by itself. And so I am going to, I'm going to get this over here, this EH. I'm going to get that over to the other side first. So I'm going to subtract off E times H. Oh, sorry. All right, E times H here as well. All right, so this side over here ooh, is going to be S minus E times H. This side is just going to be E times K. So what I'm going to do then is I'm going to divide both sides by E. And so that E will cancel. I'll be left with K, and then I'm just going to rewrite K, put that on the left-hand side. So what am I going to end up with? I am going to end up with S minus E times H, and all of that over E, like so. And there we go. Now, if I wanted to, I'm not going to do that. Should take a little bit of time. The algebraic ones, checking it is tricky because you have to go up and you have to basically take K, plug that in there, and then you got to do a whole algebraic problem, and so show that it ends up equaling H. All right, so I'm going to thwart the skirt, whatever word you want to use, that part of the check in there. It's a lot easier to do when you've got numbers to go in. Would take a lot of time to do that. Doesn't mean it's a bad idea to do it. Just with time constraints for the video, I'm gonna keep it right there. Okay. All right. So let's see. Okay. Let's do some more. Do a few more of these, and then we can call it a video. All right. Okay, so let's go with this. So I have H is equal to J cubed over C times D minus K cubed over D, like that. All right. And so now, and what I'm going to do is I am going to solve for this. It's going to seem kind of interesting. I am going to solve for J cubed. So suppose we want to get it into terms. Now, if I solve for J cubed, I could actually solve for J just by taking the cube root of both sides. All right, so let's go ahead and first solve for J cubed, and then we'll just point out the fact that if I want to know what J is, I just take the cube root of that. All right, so now looking at this, again, not worrying about the restrictions on it because I'm not plugging numbers in. But I would definitely not be able, D couldn't be zero, C couldn't be zero. That first equation would be undefined. So C and D equaling zero, not allowed. But let's get our LCD. We'll do this a little bit quicker. Convince yourself that my LCD is C times D. Right? This has a factor of C and D. This has a factor of D. So each C and D occur at the most one time. There's my LCD. So now I'm going to take my original equation and I'm going to clear the fractions by multiplying by C times D. Right? And so do that in red again. So C times D times H, C times D times this quantity. Okay, so what do I got? It's left-hand side, C times D times H. Right-hand side, okay, this CD, when I distribute it, it's going to cancel that one. And I'll have J cubed, right? This, when I multiply, the D's will cancel, the C will not. And I'll be left with minus K cubed times C, like so. All right, so if I want to isolate J cubed, what I'm going to do is I'm going to say, okay, plus K cubed times C plus K cubed times C. All right, so to do that, I'm going to end up with, all right, I'm going to end up with C dH plus K cubed times C and that is going to be equal to j cubed. So I could claim that I'm done right here. If I wanted to, I could do a little cleaning up of it and say, okay, I could factor a c out of here if I want to do some simplification. And like so. All right, so there's j cubed. Now, like I said, if you wanted to just solve for j itself, you would just take the cube root of both sides. So you would have, it would look like this. You would have c times dh plus k cubed. All of that under the cube root sign. J would be, by taking the cube root of both sides, j cubed just becomes j. All right, how are we doing? And let's do another one. Okay, let's see. All right, suppose we had 1 over b equals c over a minus 1 over c. All right, and we are going to solve, oops, for a. All right, and again, if we're going to look at restrictions in this, a, b, and c can't be 0. Notice it's all in the denominators, just like over here. C couldn't be 0, D couldn't be 0. Over here, A, B, and C, just none of the quantities that are in here, none of the variables can be 0. That would be a restriction that we would have for that. So, but let's looking at my denominators. I've got B, I've got A, I've got C. All right. So in each one of these, A and B and C occurs one time at most. And so my least common denominator in this one is just going to be A, B, C. How much simpler could it be? I mean, it's like 1, 2, 3. Okay. All right. So let's multiply both sides of the equation by the LCD. And some cancellations. We will clear out our denominators. A, B, C. Like so. All right. The B's will cancel here, and I'll be left with AC. Oh, isn't that cool? It's AC. All right, this one, the A will cancel. So the A's are going to cancel. I will be left with B. Oops, that's meant to be a B. There we go. And then, but notice I've got C times C here, so I'll have BC squared. So, and then this one right here, the C's are going to cancel, and I'm going to be left with minus AB like that. All right, so remember, we're solving for A. So I got to get all the A terms onto one side of the equation. So I am going to take minus AB over here, and I'm going to bring it over to this side as positive. And so I'm going to have AC plus AB is equal to B, C squared. All right. I'm solving for A. But each of these has an A in it, so I can factor that out. If I factor out the A, I'll have C plus B, like so. And that will equal B C squared. And all right, so then I'm going to divide both sides by that C plus B. So A is going to be equal to, I'm going to have BC squared all over A plus B. All right, now I am going to actually, for the sake of thoroughness, I am going to actually bother checking this. I didn't do it on the other ones, but let's do at least one where we're going to check it. So for time constraints, I was going, okay, let's get ourselves around that. But let me keep this over here. Move this like so. One of the things I like about when you do the videos is you don't lose your sheets. You don't have to erase the board. All right, so let's do a check here. So now to do a check, everywhere there's an A, I would plug in this particular combination. And now what check to see does the one side of the equation actually equal the other side of the equation. So I'm going to go back up. Oh, actually up here. I'm going to here we go. I'm going to go back up here and I'm going to plug in for A. So I've got 1 over B is equal to C over A. Right? And so, all right. So will this C over A minus 1 over C, will that equal 1 over B? That's how I'm going to check this out. So if I were to do C over A, I would have C over B squared, BC squared all over A plus B. Right? So that is, all right, C over A minus 1 over C. And what I'm trying to check out on this is that going to be 1 over B? All right, so now I've got, this is divided by a fraction. So I can, by my rules of division with fractions, I can rewrite this so that I'm going to have C times A plus B. So notice I'm taking the denominator of the denominator and bringing it up to the top. And then BC squared is going to stay down there in the basement. So I'm using that principle of where you take one fraction and divide it by another. And I basically just taking the reciprocal and flipping it around there. And 1 over C, like that. Okay, so there's my expression. I'm going to need to get an LCD for this. Okay, so if I'm going to combine these, I'm going to need to get an LCD. But one thing I'm going to do before I do that, I'm going to notice that this C will cancel with one of these, and I will have A plus B over, like this. I will have A plus B over B times C, like that. All right. And let's see. And how are we doing here? Except I'll bet you guys noticed something in here because in doing the check, I'm glad I did that because let's go back and let's fix this up. I bet you were sitting there going, wait a second, dude. And I could see that I was going to throw myself off here. All right, so when I went to here, I don't know if I said C plus B, but I meant to say C plus B because we're dividing by C plus B. So that's a C up here. Let's change that one. And that one like that. And let's just get rid of this and start a new line. All right, so let's double check. All right, that looks good. C plus B. Okay, that's better. All right, now let's start worrying about it. But again, I'm going to do the cancellation here first. This C cancels with one of those. And so I'm going to have up on the top C plus B. I'm going to be divided by B times C. And boy, am I glad I caught that before we stopped recording. All right, but the check is actually what got me to worry about it. Okay, so then what have I got here? Then, oops, minus 1 times C. Okay, so if I'm going to combine these two and see what they end up equaling, I'm going to have a common denominator of, I do this a little faster, a little more on the fly, but I want you to see if you can convince yourself that the least common denominator for these two would be B times C, and that would leave me with a B upstairs like that. Okay, and all right, so C plus B over BC minus B over B times C. Right, so now got a common denominator there. So everything's going to be over B times C like that. And then C plus B minus B. Okay, what do I got in here? All right, so C plus B minus B. And let's see. Oh, yeah. B over BC. And then I'm going to end up with, yep, that is going to end up working. Oh, good ending on this one. Make sure I get all my C's and B's in the right place. Yes, I do feel comfortable with that. All right. C and C are going to cancel. That is going to leave me, but we're going to have to resist the temptation of calling that 0. That is going to be 1 over B. And let's double check. It is 1 over B. So that did work. And then hopefully what you see in there is that it's a little trickier to do the checks with the when you just got algebraic solutions in there. But actually, in this one, I legitimately had made a transcription error right in there that was not set up. That's just a mistake I was making on the fly there. And if I hadn't actually gone and checked it, I would have sent you guys off with the video with the wrong solution in there. So hopefully I got the other ones right. Find out. Um, okay, so let's do just one more quick one. I can't resist. And by the way, that's I'm making a physics joke right now because I'm going to look at there's a classic problem in electrical circuits called resistors in parallel. All right, so a little quick physics lesson here. So I can't resist because I want to give you a problem in resistors. But in physics, if you hook things up to the wall socket, so I'm going to do a quick little electronics diagram, and you hooked up a couple of batteries or a couple of light bulbs. This is what would be called there are your light bulbs. Here's your wall socket, and you make a complete circuit, and your wall socket splits off to one, splits off to another. This is what in electronics class we would call resistors in parallel. Now, if we were in electronics class, I would run through all of the physics of how all of this stuff works. But basically, if you have a bulb that resists the flow of electricity based on a value called R1, another one called R2. An application of this is that if you apply all the electronic stuff, we're not going to get into that, but if you were to apply all the electronic stuff into it, you would find that the overall circuit's resistance, how resistant the two of them together are to the flow of electricity, would end up being a rational equation like this. All right, so what I'm saying is that, okay, this R is the total resistance. R1 and R2 are the individual resistances. All right, we don't have time to get into all the physics of that. But this is a place in science where we come across a rational equation. And so I'm going to challenge us. And we do this in electronics class. We're going to solve for R in here. All right. So now looking at this, I've got three fractions. My LCD is going to be actually the product of all three of those denominators. R times R1 times R2. All right. I am going to clear my denominators by multiplying by those. Right, so I'm going to have R times R1 times R2. I have the same thing on this side, except I got to make sure I multiply both of those terms by that, like so. And all right, so the R and R are going to cancel. I'm going to be left with R1 and R2. Over here, the R1 is going to cancel. I'm going to be left with R and R2, like that. And then over here, I'm going to multiply again, and then the R2s are going to cancel. I'm going to have R times R1, like so. All right, so what I'm going to do here, I'm solving for R, the total resistance of the circuit in terms of the individuals, 1 and 2. So I'm going to factor out an R here. I'm just going to clean this up a little bit. This is the same. It's R2 plus R1, how it's written here. I'm just going to write it as R1 plus R2. And so then when I divide both sides by R1 and R2, I'm going to end up with R1 times R2 all over R1 plus R2. And now this one I'm not going to check for time constraints. If I'm running over time, I probably am. And but this is one I've seen so many times. I know everything correct in there. But this is just a place where you see it. This place where, like, when I teach electronics, when I teach electrical circuits in physics classes, we see this one all the time, and we find ourselves having to solve rational equations. All right, I'm going to stop recording now.